The Gobi Desert, a place of stark beauty, vast, unforgiving, ancient, stretching over 1,295,000 square kilometers, it is one of the largest deserts in the world, a land of extremes where temperatures can swing from scorching heat to freezing cold in a matter of hours. This desert, with its rolling sand dunes and sweeping landscapes, has been a silent witness to the passage of time. It holds secrets of ancient civilizations and tales of nomadic tribes who have traversed its vast expanse for centuries. Now, amidst this timeless beauty, a new chapter is being written. It is home to a star unlike any other, not in the heavens above but here on Earth. A star born of human ingenuity and scientific prowess. This star is not a celestial body but a marvel of modern engineering. It is China's Thorium Molten Salt Reactor, the first of its kind. A groundbreaking innovation that promises to revolutionize the way we think about energy. As the sun sets over the Gobi Desert, casting long shadows over the sand, the reactor comes to life. It is a beacon of hope, a testament to our species' ability to overcome challenges and unlock the secrets of the universe. This reactor is not just another power plant, it represents a new dawn in energy production, one that could potentially free us from the shackles of fossil fuels and pave the way for a sustainable future. The Thorium Molten Salt Reactor is a game-changer for our planet. It is designed to be safer, more efficient, and more environmentally friendly than traditional nuclear reactors. It uses thorium, an element found in abundance on Earth, as its fuel. In the heart of the desert, this reactor hums with power, fueled by thorium. It is a symbol of human ingenuity and the relentless pursuit of progress. Scientists and engineers from around the world have come together to make this vision a reality. Their work is a testament to the power of collaboration and the shared goal of a brighter future. The Thorium Reactor stands as a beacon in the desert, a shining example of what we can achieve when we dare to dream big. It is a potential solution to our energy needs, a way to power our world without harming our planet. As we look to the future, the Thorium Molten Salt Reactor offers a glimpse of what is possible. It is a key to unlocking a future free from the constraints of fossil fuels, a future where clean, sustainable energy is within our reach. Thorium, a silvery metal found in abundance on Earth, holds the promise of a new era in energy production. It is more efficient and produces less waste than traditional nuclear fuels. The process of harnessing thorium's power is complex, but the potential rewards are immense. It could lead to a future where energy is clean, abundant, and accessible to all. This is the story of that reactor, the science behind it, and the promise it holds for our future. In the vast expanse of the Gobi Desert, a new star is born, lighting the way to a brighter tomorrow. For decades, we have relied on uranium to power our nuclear reactors. This heavy metal has been the cornerstone of nuclear energy, providing a significant portion of the world's electricity. Its ability to release vast amounts of energy through fission has made it an attractive option for energy generation. Uranium, while powerful, is also fraught with dangers. The process of mining and refining uranium is hazardous, exposing workers to harmful radiation. Additionally, the operation of uranium reactors requires stringent safety measures to prevent catastrophic failures. Meltdowns, radioactive waste, weapons proliferation, these are the shadows cast by the uranium age. The Chernobyl disaster and the Fukushima incident are stark reminders of the potential risks. The long-term storage of radioactive waste poses another significant challenge, with some materials remaining hazardous for thousands of years. Thorium offers a different path. This silvery metal, named after the Norse god Thor, has been gaining attention as a potential alternative to uranium. Unlike uranium, thorium is not fissile on its own but can be converted into a fissile material within a reactor. It is more abundant than uranium. Thorium is found in greater quantities in the Earth's crust, making it a more sustainable option for long-term energy needs. Its abundance means that we could potentially have a more reliable and steady supply of nuclear fuel. It is also safer and cleaner to use. Thorium reactors operate at atmospheric pressure, reducing the risk of explosive failures. Additionally, thorium produces fewer long-lived radioactive byproducts, making waste management easier and less hazardous. Thorium reactors produce far less waste. The waste generated by thorium reactors is not only less in quantity, but also less toxic. This means that the environmental impact of thorium-based nuclear energy is significantly reduced. The waste they do produce decays to safe levels much faster than uranium waste. While uranium waste can remain hazardous for millennia, Thorium waste decays to safe levels within a few hundred years, making it a more manageable problem for future generations. Thorium reactors are also incredibly efficient. They can operate at higher temperatures, which improves the efficiency of electricity generation. This means that more energy can be extracted from the same amount of fuel. They can extract almost all of the energy contained within thorium. This high level of efficiency means that less fuel is needed to produce the same amount of energy, further reducing the environmental impact. This means less fuel is needed, and less waste is produced. The combination of high efficiency and low waste production makes thorium an attractive option for sustainable energy. The future of energy may very well be fueled by this unassuming element. As we continue to search for cleaner and more sustainable energy sources, thorium stands out as a promising candidate. Its potential to provide safe, efficient, and abundant energy could make it the fuel of the future. China is a nation on the move. Its economy is growing and its people are demanding more energy. But China is also acutely aware of the environmental costs of its economic growth. The Thorium Reactor is a strategic masterstroke. It allows China to meet its energy needs without relying on polluting fossil fuels. It also positions China as a leader in the global race for clean energy technologies. China has invested heavily in thorium research. It has built a world-class team of scientists and engineers. These investments are already paying off with the successful operation of the Gobi desert reactor. The specter of Chernobyl still haunts the nuclear industry. The catastrophic meltdown that occurred in 1986 left an indelible mark on the world, casting a long shadow over the potential of nuclear energy. The images of the abandoned city of Pripyat and the desolate reactor site serve as a grim reminder of the dangers associated with traditional nuclear reactors. The image of a reactor melting down is seared into our collective memory. The fear of another disaster like Chernobyl or Fukushima has made many wary of nuclear power. The thought of a reactor core melting and releasing radioactive material into the environment is terrifying, but thorium molten salt reactors are fundamentally different. They are inherently safe. Unlike traditional reactors that use solid fuel rods, thorium reactors use a liquid fuel mixture. This fundamental difference in design offers a significant safety advantage. The fuel in these reactors is dissolved in a liquid salt. This liquid fuel allows for a more stable and controlled reaction. The molten salt acts as a solvent for the nuclear fuel, creating a homogeneous mixture that is less prone to overheating. This salt acts as both a coolant and a safety mechanism. The dual role of the molten salt simplifies the reactor design and enhances its safety profile. The salt's high boiling point means it can absorb a lot of heat without turning into gas, which helps in maintaining a stable temperature. If the reactor overheats, the salt expands. This expansion naturally slows down the nuclear reaction. The physical properties of the molten salt provide a built-in safety feature that prevents the reactor from reaching dangerous temperatures. This slows down the nuclear reaction and prevents a meltdown. The self-regulating nature of the molten salt reactor means that it can automatically adjust to changes in temperature, reducing the risk of a catastrophic failure. In the event of a power failure, the molten salt would drain into a passively cooled tank. This passive safety feature ensures that the reactor can be safely shut down without the need for active intervention. The design of the reactor allows for a fail-safe mechanism that operates independently of external power sources. This would shut down the reactor automatically without the need for human intervention or backup power. The passive cooling system is a critical component of the reactor's safety design, providing an additional layer of protection against potential accidents. This inherent safety is a game-changer for nuclear power. The innovative design of thorium molten salt reactors offers a promising solution to the challenges faced by traditional nuclear energy. By addressing the safety concerns, these reactors have the potential to revolutionize the way we think about and utilize nuclear power, paving the way for a cleaner and safer energy future. Section 5. A world transformed, thorium's global impact. Imagine a world where every nation has access to clean, safe, and affordable energy. This is the promise of thorium power. Thorium reactors are smaller and more modular than traditional nuclear reactors. This means they can be built in factories and shipped to locations around the world. Developing nations could leapfrog the dirty phase of industrialization. Remote communities could have access to reliable power. The environmental benefits are equally profound. Thorium power could help us combat climate change by reducing our reliance on fossil fuels. It could also power carbon capture technologies, cleaning up the atmosphere. Section 6. From desert sands to megacities, China's thorium roadmap. The Gobi Desert Reactor is just the beginning. China has ambitious plans to build more thorium reactors. A larger 10-megawatt demonstration reactor is already under construction. Even more ambitious projects are on the drawing board. China envisions a future where thorium powers its industries, its cities, and even its transportation systems. Thorium-powered ships could sail the oceans for years without refueling. High-speed trains could crisscross the country, powered by clean energy. China's commitment to thorium is not just about meeting its own energy needs, it is about creating a new model for sustainable development, one that other nations can follow. Section 7. Beyond electricity, thorium's versatile power. Thorium's potential extends far beyond electricity generation. The high temperatures achieved in these reactors open up a world of possibilities. One of the most promising applications is hydrogen production. Thorium reactors can be used to split water molecules, creating hydrogen fuel. This hydrogen can be used to power cars, trucks, and even airplanes. It can also be stored and transported, providing a clean alternative to fossil fuels. Thorium can also be used to produce high-grade heat for industrial processes. This could decarbonize industries like steelmaking and cement production, which are major contributors to greenhouse gas emissions. Section 8. A lost opportunity regained from the US to China. The story of thorium power is one of missed opportunities. The United States actually pioneered thorium reactor research in the 1960s. However, the program was abandoned in favor of uranium-based technologies. China, recognizing the potential of thorium, picked up where the US left off. It studied the declassified research, invested in its own programs, and now stands at the forefront of this technological revolution. The US is now playing catch-up, but China has a significant head start. This highlights the importance of long-term vision and sustained investment in scientific research. Section 9. Challenges on the path to a thorium-powered world. The road to a thorium-powered future is not without its obstacles. Molten salt reactors present unique engineering challenges. The corrosive nature of the salt requires special materials. The online processing of the fuel is complex. Waste management, while less daunting than with uranium, is still a concern. The proliferation of uranium-233, a potential nuclear weapon material, is another issue that needs to be addressed. However, these challenges are not insurmountable. Scientists and engineers around the world are working on solutions. New materials, advanced designs, and innovative waste management techniques are being developed.